There we go. All right, so here's a few news things before the official lecture. This is something I haven't heard much of lately. Good news. I listened to this podcast from Democratic operatives, and it was very interesting. 2 minutes right in here, they talk about what happened in Wisconsin. My sister was in Wisconsin, but I didn't know the whole story. They had this election where people were forced by the Supreme Court to go vote in person, even though it was dangerous and there was a lockdown order. And that's because the Republicans have totally rigged the election there. They have packed the Supreme Court. They have gerrymandered all the districts. They have totally pulled every kind of dirty trick for voter suppression, and they lost. The Democrats finally got so mad at all the blatant cheating that the Republicans are doing that they actually got out and voted. So this is what I think all of us have been waiting for many years. So it's nice, at least in one case, the Democrats actually got out and did something. Democrats outnumber Republicans 2-1 in this country, but they don't bother to vote. And so this is, I think, the fundamental principle of America is that you can't fool all the people all the time. There comes a point, at some point, when the people get so mad of being abused that they actually go out and vote. So maybe we'll get there. So this just came out. There was this famous case in the news over the last week of an aircraft carrier where the people were getting sick on the aircraft carrier, and the commander of the aircraft carrier could not get any action through normal channels. So he went out. He was invited by a high-level executive in the military to go outside the chain of command. He said, if you have a problem, contact me directly. So he did contact him directly, and that guy flew to the aircraft carrier to give a 1-hour raging rant imitating Donald Trump, firing the guy, attacking the media, repeating all of Donald Trump's standard actions because the previous leader of the military was fired by Trump. And the new leader of this part of the military has gotten the lesson that what you must do is act like Donald Trump in order to not get fired. So he fired the guy, and then he was forced to resign after that, after the recording leaked of him doing this, which was considered outrageous. And so people are getting very concerned. I listened to a very interesting interview with a high-level military person that said the U.S. military is in great danger of not being ready for action because they're getting sick. And anyway, so what they need to do is roll in all of our Navy ships and take all the people off them and disinfect them, and then put all the people in quarantine for 2 weeks and put people on there who are only not sick, and then not ever let them go on land again until there's a vaccine. You just don't, there's no other way to have a ready Navy of soldiers that are healthy enough to fight without doing that. But right now they're refusing to do that. But in this particular one case, they did that, and they tested all the people, and an enormous number of them are sick, and an enormous number of them are symptom-free. 60% of the positive cases have no symptoms at all. And what that means is we're going to have great trouble ever getting out in public life here, because it's very hard to detect people. And in America, because of our enormous shortage of tests, which is getting worse, they refuse to test you unless you have symptoms. And apparently we're missing 60% of the infectious people spreading the disease by doing that. What we must do is have so much testing that we can detect people who are asymptomatic, and that would require increasing the number of tests per day by a factor of 200 in America. And we seem to be nowhere near doing that. So I do not know how we can ever go out in public without that. We will see. Supposedly some states are going to come out of lockdown in the next week or two, and we will see what happens. But it doesn't look good. There's this theory I've heard about that the SARS is actually a weapon developed in a Chinese biowarfare lab, and I totally discounted it as just paranoid nonsense. But anyway, here's an article, relatively well thought, trying to present the evidence of it. So I put it in the news links. You can see it if you want. Perhaps there's something to it. Nobody knows. There apparently is a drug that's helping. There's this quinine drug that Trump is pushing, which seems to be completely useless and actually harmful and damages your heart. But there's another one called remdesivir, which is apparently showing pretty good effects. But although these are not the proper medical studies, they should be double-blind under proper conditions yet. But hopefully, this would be a very good thing. We could reasonably have. Maybe we'll have a good treatment, at least, for the people who get coronavirus. The vaccine must be at least a year out because you have to try it for safety. And the antibody tests seem like they're going to be essentially useless. But at least treating the people who get sick looks like something we might be able to accomplish. Anyway, the lockdown is incredibly effective. It's extremely expensive, but it's incredibly effective. California locked down just a few days before New York, and look at the difference. New York State had 1,000 cases per 100,000. In California, only 61. New York has 50 deaths. In California, it's amazing. And that's what they say. Even just a few days earlier action makes an incredible difference, of course, because there's less people out there geometrically spreading the disease. So our local government has done a very good job of locking us up quickly, but the next step is to try to resume business as normal, and that is going to be tough. And I think nobody's figured out how to do that yet. So Libra is still around. This was Facebook's cryptocurrency. They're still trying to do it. I don't know if anybody wants to do this, but anyway, they're talking about it. They're still making plans to try to meet international regulations and tie it to coins. We'll see if something ever comes of that in America. And I think worldwide, everyone has pretty much decided that we all hate Facebook and distrust Facebook so much that nobody wants to have anything to do with a cryptocurrency from Facebook. But we'll see. This was very interesting. The unkillable Android malware came out about a week ago, and it was analyzed by an American company, Malwarebytes, and they couldn't quite figure out how it works. But now finally Kaspersky has stepped in. And Kaspersky is famous for the best technical analysis, and they figured out how it works. And I'm thinking I got to try and see if I can get this stuff working on Android phones in the mobile phone hacking class. What this thing does, the point is it installs an app on your phone, which is malware, and then when you try to remove the app, you can't. And even when you reset the phone to factory defaults, it still doesn't get rid of the malware, which is pretty impressive. So what it does is it installs, it roots your phone and uses a Trojan called Triada, which roots the device, and then it installs a set of malicious files directly on the system partition by rerouting the partition in write mode and declaring them immutable, which means they cannot be deleted without removing the immutable attribute first, which is something people don't necessarily know about using the chatter command. And now it creates a folder called System X bin, where it has stuff that will reinstall the malware every time you reboot the phone. So it's very interesting. And the end result is, of course, most normal users that get it and most normal tech support people that help them cannot get this stuff off the phone. So I'd like to play with that in an emulator and see if I can make it do something interesting, and we can see how to handle it. So these guys went into detail with the plan, the coronavirus contact tracing plan from Google and Apple. They explain technically how it works. It has a secret key on your phone, and then it generates these things called tracing keys. It's calculating a whole series of hash values every 15 minutes on your phone from a seed, and then it's dumping a public key related to that, which is just 32 bits. So it's not even the whole hash value. It can't be traced back to you, but it's got enough bits that it's unlikely to collide with someone else, and that goes to some server. And then if you get a positive coronavirus test, the server has a list of those numbers, and the number tells you not only a clue of who someone is, although it's all anonymized, it also changes every 15 minutes. So that you can download the list, and your phone will figure out not only if you were near a person who was positive, but how long you were near them. So if just there's one number, that means you were not in their vicinity for more than 15 minutes. So maybe that doesn't matter. If there's 2 or 3, then you spent some time at that person, and that probably means you need to isolate yourself. And it's all done anonymously, and they go through it in great detail here. And so, as you might hope, Apple and Google really did a good job planning the cryptography and everything. But the problem is, of course, they can only do the cryptography. Now, somebody has to write the app, and they have to not foul up writing the app, as we can see is a lot harder than you might think. And we have to have enough tests so everybody can get tested and efficiently deploy the thing. And people have to trust everybody enough that they will all really install this app and use it, when it's probably not going to be possible to force everybody to use it. So, this is a lot like blockchain voting. You can make a technical solution to the technical part of some technical parts of it, but there's a lot of real world problems that you can't solve so easily. Anyway, so let's get down to this class. The semesters around here are strange. By the time you hit midterms, you're really almost at the end. And so this class, we're down here. There's only 3 more lectures left. Then your last class, I haven't got a topic. It may just be a time for people to catch up. I'll see if there's something worth talking about then. But anyway, here we are on the 16th, cross-site scripting, a couple more lectures on other techniques coming up, and then the final exam will be up for a week after that. So I already have on the Canvas course server that you're using, it has a comment that explains how your midterm grade was calculated. And if I haven't put it up, I'll put it up soon, how to get your final grade calculation from there, so you can all see what's coming. If you don't have enough points, there's extra credit projects to do. And if you want something else to do, you can do the COBOL CTF if you're interested in that. I've got various links to it down here, one at DerpCon and so on. Anyway, but there should be enough projects to keep everybody out of trouble. And so let's talk about cross-site scripting, which is a huge topic. And let me make this big. All right. So the point of cross-site scripting, we've done a bit of it already, is you have, you can put code on a page which runs on another page. And this is just like all the other command injection we've done in this class. The end user should only be putting in data like usernames and passwords and tweets and Facebook posts, but under a surprising number of conditions, you can put in data which ends up being treated as code by the web application and even perhaps served up to other people as code. And that's what happens here. This is extremely common. Something like 80% of all websites have cross-site scripting vulnerabilities. It is not considered a high value risk by most companies because it does not let you run code that runs on the server and lets you take over the server and steal their data. It just lets you put code on the site that runs in a user's browser and steals their data. And companies don't regard that as a big risk when you're just stealing data from their customers one by one. It's not like you're breaking into the company and stealing their proprietary data. And certainly, from a viewpoint of the number of users affected, and a viewpoint of the legal consequences, it is true that this is a smaller problem for the company, but it's still a problem. So there's three basic kinds of cross-site scripting. Reflected cross-site scripting is the most common one, where you type something on a page and then it reflects back to you and runs in your browser. And that's the most common type here. So I guess I'm probably just going to leave this shrunk down to part of the screen throughout here. And I should have a page of demos over here. There we go. All right. So let's see if I can put that over there and this over here. We'll see if it works. I can. All right. So here's the, see if I can do this. Control. There. All right. And refresh this. All right. So I've got a message here, which was intended to have some innocent thing like hello. And so when you submit that, it has a page that just uses that for the error message. So some of the data I put in is used to reflect back to me here. This is very common. And so, of course, if you put in a script, this is a common one to test it, then you get a pop-up. Although many modern browsers detect this sort of script and block it. Firefox doesn't, that's why I'm using it. But more and more browsers are mitigating this, just like browsers are mitigating pages that are HTTP and not HTTPS. A considerable number of weaknesses have become so popular that browsers are beginning to put in mitigations. But anyway, you can do that sort of thing, and we'll get to these other ones later. That's reflected cross-site scripting. So the user can code runs that the user didn't put there. Now, in print, what happens is an attacker somehow manages to add script to the page, and that script steals your cookie. That's the common way it works out. So if you have a session cookie that identifies you and there is no anti-cross-site request forgery token, which means that cookie can be copied and reused on another system, it's not tied to anything secondary like your IP address or something, then all I have to do is steal that cookie. And that means if I can send you a malicious link that will contain script, so when you go to log into the page, extra script will appear on the page, then I can steal your cookie and then I can hijack your session. So that's the most common way it's done. And if you have a persistent cookie, like most people have, they're just logged into Facebook or Twitter all the time. So then there's a cookie sitting there that can be stolen by anybody that can get you to redirect to any page on that domain, which has a cross-site scripting vulnerability that lets me add script to that page. And that's what something like 80% of all websites are vulnerable to. Now, you can only do it from the same domain. If I own evil.com, I can't steal your target.com cookies. I can only steal it by going to a page that your browser will interpret as being at target.com. But cross-site scripting lets me add some extra code to a real target.com page, and that's why I'm able to steal your cookie. So I'm able to write a script, even though I'm not authorized to add script to target.com, and I'm able to fool your browser into believing that that script came from target.com. All right. And another version of this stored XSS, where instead of having a URL with some kind of script embedded in it that works just once, I can store it on the server, and then it will affect everybody that sees it. Any page that posts stuff, so that I made message boards, you can put up a script and everybody that views it will see it. And this happens a lot. So that's the very another quite common type. A more modern type you hear about is document object model based XSS. These are all essentially the same thing. DOM is where you have data collected from the user and it's used to construct part of the next page by using the document object model in JavaScript. The server's response doesn't exactly contain your script, but when it's processed, it will reconstruct the script on the end user. So I think I've got an example of this. So let's take a look at that. That's number 4. So this is DOM-based XSS. So this page is actually built with a script. And it's taking, let me make this bigger. It's taking, there's data, the message hi that came from me here was used in JavaScript to construct the contents of this box. So it really is a lot like stored or reflected XSS, but in principle, I can put script up here. And so I think I have an example of that. Yeah, here's one that puts so this hi came from up here and appeared for me, but it passed through JavaScript on the way there. That's why it technically passed through the document object model, but it amounts to the same thing. It was not put on that website by the developer. It was inserted into the URL by the attacker and processed in your browser. And this, this is a very simple fundamental problem. I remember, I'm so old, I remember when telephones were relatively new and people were worried about telephones. We had party lines when I was a kid, and people say, you don't know who's on the other end of a telephone. And your browser doesn't know who put the code on there. Some of the code came from the URL bar, some of the code came from the server, and all cross-site scripting and exploits the fact that your browser doesn't really understand exactly where all the content came from. And that's why it's a lot better to use HTTPS, but HTTPS can't save you if you have cross-site scripting vulnerabilities, which is another way a bad guy can add malicious code to the page. So there's some Cahoots about that. Let me bring them up. This is 12A. And I got to use this browser for Kahoot. I have to set up a page to record the scores, but I can do that later. So hope I've got it in my favorites. I do. Good. 12A. All right. There. All right. All right. Got 13 people. 9 might be all I'll get. I'll give it a few more seconds. All right, I guess 9 is it. Well, let me check my chat messages and make sure. Up here. Just trying to arrange it so I can see everything. Okay, nothing's coming in. All right, good. All right. So what attack steals all the data in a database? Right. None of these can. That's why cross-site scripting is not taken so seriously. SQL injection is one of the attacks that can steal all your data, and they take that one a lot more seriously. All right. What attack can steal session cookies? Okay, any kind of these can do it, but that only steals the data from one user at a time. All right, what's the most prevalent web app vulnerability? Cross-site scripting, of course. All right, so in a search page, a script runs on the results page. What has happened here? That's simple reflected cross-site scripting. I suppose in principle it could be DOM-based, but it usually isn't. Usually when you search for something, the next page will say, I search for shoes, the next page will say, you're searching for shoes. And that is just reflecting the data I put in. And if they don't filter it, that script would get in there. Yeah, the gist of the DOM side, I know people, when I first heard about, I see a comment from Ed asking about DOM-based scripting. Let me finish recording these scores and then we'll talk about that. Steve and Phil. And Peter. Yeah, I used to think DOM-based cross-site scripting was complicated, and now I really don't. So let me just, in fact, it seems kind of silly to me to even make a big deal about it being a different thing. The point is reflected cross-site scripting, you put in the text, and if I put Fred here, I get rid of all that old junk there, Fred, this Fred here is just sitting there directly in the source code, Fred. The server took the Fred I sent up and just put it and calculated what to put on the page right there. So it was the server that took my data and put it in the page that was displayed to the user. But if I do DOM-based scripting, it just uses a more complicated procedure to do the same thing. So here, I specified hi, and the hi was put there by my browser, not by the server. If I view page source, the hi does not appear literally anywhere in here. Instead, it has these scripts, and the script goes up and finds the characters up here and copies them onto the part of the page I can see through JavaScript. So that's the difference. It's just technically more of the processing is happening in your browser. So I guess that's why it looked a little more complicated to me at first, but the end result is about the same. Anyway, I hope that helps. So let's go on to some of these others. So, all right, so here's some real world examples of how this worked out. In Apache in 2010, people were actually able to change the Apache source code. What they did was find the issue tracker where you could post bugs about Apache, and they found a stored cross-site scripting there. Now you can put a storage site script. He was able to inject code, and an administrator filed a bug report, I think. So it's not, I don't know if you're going to call this storage cross-site scripting. I think you do, but he injected code, and the administrator clicked the link, and then they were able to steal the administrator's cookie. So by posting a bug report, which would be read by administrators, you have a pretty good chance of getting a high-value cookie, and now they can get into the system as an administrator and upload malicious code, which will then be downloaded by the users. So that's a game. All right. And then, of course, they were able to add more code. Now they have administrator privileges and steal a lot of data and make a lot of trouble. MySpace is the famous MySpace worm. MySpace was the precursor to Facebook. It's totally gone now, I think, but everybody used it for a while to post their comments about their life. And Sammy Kamkar, a famous hacker, found how to bypass their cross-site scripting filters. So he was able to put a payload in a post on his MySpace page. So he added this to his user profile that made everybody who viewed his profile add him as a friend and put the script in their profile. So that anybody that viewed their profile would add him as a friend. So in a matter of hours, he gained over 1 million friends on MySpace and became the most popular person ever on MySpace, which was just a way to show off his hacking skills. And he's still around. Sammy Kamkar, he writes a lot of hacking tools. I think he managed to avoid getting in serious legal trouble for this. This was, of course, illegal, but anyway, he's still around and has a lot of web-based hacking tools and such. Anyway, this one was pretty funny. Strong Webmail was one of the first two-factor authentication solutions. And this guy was so proud of it, he offered a $10,000 challenge to anybody that would hack him, saying, nobody can hack my email. So somebody hacked him immediately. Don't say this to professional pen testers. What they did was they found a stored cross-site scripting, so they were able to use it to steal cookies from his machine, and that's how they got in. And in principle, his two-factor solution should still have saved him, which is why he felt so confident, because the idea was even your password will not let you in without calling you on the phone first. But there's a convenience feature. So if you're using a trusted machine, instead of calling you on the phone, it'll take a cookie from your machine to prove that you're trusted. So by tricking him into clicking on an attachment and stealing the cookies from his machine, they were able to bypass his two-factor solution and get in. And presumably won the $10,000. I don't know if he actually paid up, but anyway, never do that. Never advertise your product as being unhackable. You'll just be made a fool. Your product might be good and it might have some security features, but nothing is unhackable. All right, and Twitter had a lot of cross-site scripting worms. I remember this just all the time, weird scripts running. There were 2 in a row. So a bunch of people had pop-up socks and all sorts of games spread around on Twitter based on this. So you can have a virtual defacement. You can even do it with the simplest one here. If you just have a cross-site scripting code, we made one here where you pop up a box and you could you could also steal your cookie and send it to a third party to get a user's account. But here's another thing you could do. You could just add code for some other type of code to the page. And now you'll see error, please go to our new page. And I've seen payloads that actually add images and make it look like it's a Google CAPTCHA or something. So it displays some extra code here, which causes the user to do something bad. And all that code is technically up here in the URL, but a normal user won't notice that. And you can hide it behind a URL shortener or something. So all this active code was not put there by the developer, but added there by the attacker. So I can actually change your page and make you, the sky's the limit with that kind of injection. It's just a test of your ingenuity. It's social engineering now, how much harm you can do. So you add actual working functionality into it. And here's an example from the book where all this code up here puts a whole fake Google page asking for credit card numbers on here. So if you have a cross-site vulnerability, it can be more harmful than you might think. Anyway, all right, if you do that kind of attack where you steal session cookies, it's still kind of painful for the attacker because now even if they make an automated system like Sammy Kamkar made one where he didn't have to interact with it. It would just add him as a friend. But if he wanted to steal the session cookies and get into people's accounts to do things like steal their bank information, you'd have to harvest all these cookies and then connect to all the servers. So it can be pretty labor intensive. And you'd have to put some thought into how to really automate all of that. I know the target attackers that stole all the credit card numbers really put a lot of work into it. And they used a lot more techniques than cross-site scripting, but they actually wrote specialized malware that would live on the payment processors and harvest the RAM and hunt through the RAM to find just the credit card numbers and get a small amount of data and then compress and sneak it out. And they had to automate all that. It's just like good guys have a problem of how do you handle the scale when all your customers come in to use your site. The bad guys have a problem of scale. In fact, I should mention Nginx, the rapidly growing alternative to Apache. Nginx was originally written to run botnets of compromised machines because Apache was too slow. So they streamlined Apache to be much faster, because if you have a botnet of like 10 million machines, it's hard to control them. Your command and control server gets overwhelmed with the traffic. So they had to write superior tools to handle large amounts of traffic. And then it was repurposed for normal commercial use and turned into a web server. And the point of Nginx is you can handle more requests per second than Apache. Did Mandiant do the forensics in a target attack? I believe they did. I don't know if it's ever been publicly stated that they did, but there's a description in the malware analysis course, or else the incident response course, I forget which one, where Mandiant gives a case history that sounds very much like Target to me. Mandiant basically invented incident response. So any of the really big advanced persistent threat hacks, anybody that could afford it hired Mandiant. They're the ones that can really help you get rid of those guys. Now I think they have some competitors, but for the first several years, they were really the leader there. Anyway, so like I say, if you put some kind of payload that affects every person that goes to a page, then you can just collect all the cookies until you finally get an administrator to go there. Unless you're able to do like what the Apache people did and carefully craft a message that will be read specifically by administrators. All right. So you have autocomplete and so on. Sometimes if sites are in an Internet Explorer's trusted site zone, then they can run script. That's Internet Explorer's model. And I don't think IE is that big a player anymore, although inside companies it often is. But knowing the IE security model was very important for Internet Explorer attacks. And in that case, what you wanted to do was use a site that would be considered trusted so that scripts would run, because Internet Explorer would not allow scripts to run on untrusted sites. I don't think Chrome or Firefox use that system, but Microsoft does. At least they did through Internet Explorer, and I think Edge still works the same way, but I'm not really sure. ActiveX was Microsoft's precompiled code method, very powerful, turned out to be very dangerous, and I think ActiveX is on the way out. Like Flash, ActiveX turned out to just make more trouble than it was worth. All right, and so once you've got on the client, then you might be able to make keystroke loggers for keys typed into the browser and do port scanning and such. Yeah, VBS. No, and we'll get there. VBScript is mentioned in the book, and it's totally deprecated and gone. I don't even think Microsoft supports it anymore. So Flash and ActiveX and VBScript are all pretty much out of date, I think. All right. So let's take a look at another Kahoot, which would be here. 12B is here. Good. And let's make it big. To be fair, I think VBScript still runs from the command line on Windows machines, but not in the browser, something like that. It's pretty much gone. Might not even be installed in modern versions of Windows. If there's a student that's more up to date on Windows tech support, feel free to chime in. I moved to Mac years ago, and I'm not really up to the latest Windows, up to much on the latest Windows features. Aha, I think I know who that is. All right, let's try this. All right, which attack is labor intensive where you have to collect and use cookies one by one? That's session hijacking. All right. So that's more appropriate for things like whaling. Whaling is when you, instead of fishing, just trying to get people, you try to carefully get important people, like rich people, where it's worth investing your time in the people, it's targets one by one. All right. Switch attack got a $10,000 prize. was strong webmail. All right. Which attack gained administrative access. Now is the Apache server. Good. All right. And which attack did Sammy Kamkar do? The MySpace attack. Good. Called it the Sammy worm. All right. So Ken. All right. Bill for the second time. Sean. Good. Okay. All right. So we're right on track here. Let's get rid of this. And I thought it would shrink down, but I guess not. I'll do it this way. All right. So we talk about how you deliver these attacks. You can, most common way is sending a phishing email or a tweet or something where people click on it, instant message, or any other website that lets you post HTML up. You can make watering hole attacks. These hit the news when the Chinese government used these to attack Tibetan activists. They would put up a news page or compromise a news page of a topic of interest and then wait for people to come to that page. This is why there was a common belief for a long time that porn was dangerous and you get your machine infected by going to porn. And there was a test of this about 8 years ago where they said, what is the most dangerous type of website to go to? They said the most dangerous website to go to is if you Google the current news thing, like whatever hits hot in the news, you Google it. That's the most dangerous thing because these watering hole attacks, they automatically generate pages hitting whatever the current hot search items are that will have high search value hits. And Google tries to prevent that, and they might be more successful. I know they actually got one of my friends this way. They're an AOL user, and AOL seemed to frequently make them not able to log in. And so when you Google like AOL login problems, all the top 10 hits were fake pages with malware to trick you, pretending to be the AOL help desk or something. Anyway, that's watering hole attacks, where you try to make an attractive page that will just attract people to spontaneously go there. And now they're not clicking a link in an email and they really don't have much of a clue. But if you Google a topic on Google News, as far as I know, that was what happens. You Google it on Google and then you get in. Google tries to prevent this. It may be better now, but I rather doubt it. I know when I search for technical topics, I very often hit these pages that are just automatic pages full of like many copies of the words to make me go there. So you can deliver these things. Another thing people do is purchase an ad. This is a great way to deliver malware. When you purchase an ad, the most safe thing would be you have to have a static page. You have to email us the image. We'll put it on our page and serve it from our servers. But that's not what people do. They just rent you a space, like a 2x2 inch block. And what goes in there is whatever you put on your server. And therefore, you can put up an innocent ad, buy it, and then after people are distributing it, you change the contents of the ads to be malicious, and it will be a while before they catch you, and all that time you're infecting people. So this is quite effective, especially if you can just purchase the ad with a stolen credit card or something like that. So that's a common technique. So this is in-band to deliver stored cross-site scripting, where you have things like the names of files, messages posted up there that are just sitting there and get and appear on the server. Another thing you can do is have a cross-site scripting that comes in through some other way than the usual way data comes in, like email from the server or something like that. You can chain cross-site scripting, which is what you usually have to do because in itself, cross-site scripting is usually too weak to accomplish anything spectacular. It's part of a chain of attacks to get in. All right. And if you look at the Pwn-to-Own contest, where people win big prizes and great fame for hacking the latest versions of browsers and operating system, it's almost always a chain of 3 or 4 vulnerabilities they have to put together to really take over the machine. So your cross-site scripting might allow you to put script in a displayed name. Then you might find some way to do that to other people's names. Then you add token stealing to every username. Then you somehow find out which one of them is the administrator. So, it's not really that the cross-site scripting itself accomplished something awesome. You have to add more exploit development to it after that to make it really powerful. All right, so if you want to find these things, the most common thing is you just have an alert box, and you see a box pop up. This is the fastest way to do it. This is where script kiddie sorts do it, but this won't find them all because there's a lot of cases where you can't just exactly inject a script, and yet there is a vulnerability. So because they're removing script, they're removing the less than and greater than sign or something like that. So some of these modified attacks, like we've talked about before, might get in. Then there's a lot of them where they don't exactly return exactly what you put up. It is passed through some processing and altered. So what you might do is just put in a benign alphabetical string and then look to see if that string comes back. This is essentially what I do with all these Android applications, where I create an account, click the Remember Me button, and then I search through the operating system to see if it stored my password somewhere. So you just choose a unique string like this, my XSS test or something, and then submit it everywhere, and then monitor responses to see if that string comes back to you anywhere. And you can script that. And then each one of those is a likely cross-site scripting injection point. It's where something you put in came back to you, and now the question is, could that have script in it? All right, and you have to test these one by one, of course. All right, so here's an example of that. If we take a look at example number 5 here. Here we've got, this should be 50% in both of these, I think is the original plan. Let's put it back to the original case. All right, and so if you submit that, it just resizes the image to be 50% in height, 50% in width. But if I put in other data here, and then I view the source cage, then I'll see, let me make this bigger. The data I put in went here. So I apparently control data inside this tag. So this data is inside an image tag and inside some quotes. So it's not, if I try putting in the usual kind of injection here, like this kind we used up here, if I try injecting this stuff, it won't work. So if I put that in here, and there's no pop-up. Now the reason there's no pop-up is because it did insert that stuff, but it's in quotes. So it's not able to inject a script tag. So I have to inject something a little more crafted. I have to put in a quote and a closing bracket to finish it. Yes, this is, well, is this, no, it's not stored XSS, it's reflected XSS. Because I haven't actually stored it on a server. It's not going to be served up to all the viewers of the page. It's technically right here in the URL. It's up here. So it's only affecting me. All right. But if I could send somebody else a crafted URL, then they would see it. But it's not going to affect everybody. Anyway, so I wanted to do it, and I thought I had, but maybe I fouled it up. Let's go back to here. Let me take this. This should be a solution that does it. Let me close these extra ones because I'm getting a little confused. All right, and put that in here. There. Yeah, so now I get the pop-up. And all it is, if you look and see, I've got some also collateral damage down here because I broke the structure of the page to some extent. So if I go here and view page source, you can see I closed this image tag with the height at 50%. Then I was able to inject this script stuff, and now I had this extra HTML stuff hanging out that I didn't take care of. Now I could have injected like another image tag here or something to use that up, but I didn't. So it had some collateral damage. The image is distorted and so on. But anyway, that's an example there. Here's another one that might be useful. If you don't have to pop things up right away, you can booby trap it so it will take advantage of later motions of the user. So now it's fine, but if the user clicks on it, then it runs the script. So, you can inject JavaScript code to do whatever you like. And all right, if these things are hard for you to tell apart, They really are all essentially the same thing. It's just minor technical details on exactly how you manage to get the script to appear in the user's browser. So that's in an attribute value where you're going to have to use extra quotes and punctuation marks to get it to run correctly. If the data is inside a parameter like this, then you're going to need to add more punctuation marks to make it run. And here's more examples. If the data is inside a href, then you'll have to add a JavaScript handler to make it run JavaScript in there. It's all just figuring out how to write valid HTML given where the reflection appears. All right, so if you're going to probe filters, one common type is it identifies an attack signature and blocks your input. That's what we keep saying is by far recommended. If you find anything fishy in the input, you should just not process that data at all. Make the user submit clean data. But what's more common is it tries to sanitize it and keep using it, or truncate your attack to the maximum length. And if that's true, then those are pretty easy to defeat. So if you have a signature-based filter, which I see an awful lot in like Microsoft-based systems, potentially dangerous thing was detected from the client. I see this all the time, created some kind of exception. Then you can just find out exactly what triggered it. Now, remove characters from the attack bit by bit until it quits complaining, and you can deduce from that exactly what it's looking for to trigger it and try to find a way to slip past it. All right. So if script is blocked, you can put in object data. You can put in base64 encrypted code. You can, in various ways, this is script alert 1. You know, there's a lot of ways to put in data which will be processed by a browser as JavaScript, even though it won't look like JavaScript to the filtering engine. All right, and here's one of the examples here where script is blocked, but other things are not. So here, if I try to send up the script tag and submit it, it doesn't run, and see, it detected it. You're an evil hacker. It's got a script on my server looking for the word script, and if your injection contains something that matches the pattern, you will be blocked. So I have to find a way to inject a tag which will run as a script tag in the browser, but will not look like a script tag on the server. And this one failed. So even though technically the script tag was inside another tag, that wasn't enough to fool it. But here's the base64 encoded script, which is going to just take data and tell the browser the data is base64, so the browser will undecode it. But apparently the server-side script is not smart enough to undecode it. So the server-side script did not recognize that I injected something, and it ran in my browser. So that's the fundamental thing we talked about all semester. Because you have multiple servers handing data off, you can send data which will pass the sanity check at one server, but in fact turn into something malicious at a later stage of processing. All right, so there's a bunch of these that will run on ready state change. That one I showed, when you click, something happens. There's all these other JavaScript handlers that will run, like onActivate and so on, that will run automatically without the user clicking on anything. And in HTML5, there's one on autofocus and blur and things like that, in closing tags when you move the mouse and so on. There's just all these JavaScript features that can trick it into running any JavaScript code you inject. All right, there's pseudo protocols, JavaScript alert. You can put them in iframes, embed them. You know, there's just an amazing amount of JavaScript tricks. And it's hard to imagine a filter actually being smart enough to detect all these things. You can even use style sheets to run XSS. You can obfuscate this attack. You can insert null bytes. You can take away, you can change the case. Wherever you need quotes in JavaScript, you can usually omit them and it'll still work. There's just lots of ways to do it. The point of null bytes is that if the defense system uses C, the null byte will terminate the string. And most high-performance systems are coded in C and therefore vulnerable to that. You can add invalid tags. Here I've got an X tag. It's not an image tag or an ahref tag or anything. It's just an invalid HTML tag, but your browser will often still let the JavaScript handler inside here run. even though the fundamental HTML tag is missing, because the logical structure of your browser is it tries to process HTML, and then it passes the image handlers to another section, which might not know that this came from an invalid HTML tag. So, it's a smaller version of the same thing. You have levels of processing, and one stage doesn't know that something went wrong at a different stage. You can also hit the base tag hijacking. Some people, you can set the base in HTML, and now all relative URLs refer to that domain instead of the intended domain. So now you can load images and scripts from some other server than the one that the developer expected you to use. When you need spaces in tags, you can often insert other things like special punctuation marks, like a tag encoded in various ways. This is a tab, a character turn, and a line feed, and so on. You can often put in comment characters and such instead of spaces. So again, you'll fool filters that expect to see the word script followed by a space or something. And you can put null bytes in all over the place. You can put in backticks instead of apostrophes frequently. All right. You can change the delimiters to be strange things. So, there's just a bunch of malformed structures that will in fact run in browsers often, even though they're not valid, and they'll often fool the filter. So here you're adding strange characters in the middle of the alert, which will still be accepted by the browser. You can put numbers in decimal or hexadecimal, and might be able to get in that way. This was an Microsoft web server vulnerability from several versions back, where it would decode from canonical form twice. So you could put %25, which would decode to a percent. And now this would turn into %3C, and that would now be the less than sign. So this strange construct would turn into a less than sign, and so your filters that tried to remove less than signs would be fooled. All right. And you can also use Unicode, Universal Unicode, which has many ways to express characters. And often you can add extra brackets like this, and the browser will accept it. All right. There's a web developer add-on even to help you, because this, by the way, even aside from a security issue, this is a usability issue. Web developers have a problem that you really have to make it look good in all the available browsers. And until maybe 3 or 4 years ago, Microsoft was terrible for not obeying the standards. So if you had to highly customize a page to make it look good in Internet Explorer, and then make it look different, design it differently to show up in Firefox and Chrome. They're all being more standardized these days. But anyway, there are a lot of tools available to help web developers try to fix their code. And here's one that will let you see the generated source. Firefox and all other browsers try to fix broken code. And you might want to see what will happen to your code after it's gone through that processing. So there's a lot of character sets that let you express things differently. Here's UTF-7, US ASCII, UTF-16, many different ways to express this, different characters that will add up to the special characters you want to put in. And you can set the character set in the HTML code to tell the browser which character set you're using. Shift.js is a technique developed for Japanese characters, and this means it used 2 characters to create a character. So you could just input this F0 at the end of your input, and that will then eat up the quote that comes after it. So I have this alt tag that I control, and by putting in this character, it eats that quote. And now all this is eaten up by the quote. Now some other field I'm able to inject to later can have characters that will run. So another nasty trick. All right, and then if you want to stick script code in, we've talked about these before. You can use the eval function, extra escape characters. There's just an endless series of ways to sneak it in. The A to B code, or B to A, is a code that converts base 64 back to readable text, so it's a way to sneak things in. You can construct strings. You can just have a series of strings that add together to add up to alert, or express it as numbers or as base 64. So it's a sort of fragmentation attack where any kind of defense system will not find enough characters in the attack string to recognize it. You can use, aside from eval, you can have other ways to sneak it in. All right, there's just a dizzying number of ways to do this. And you can mix together the various techniques. So, and VBScript is in the book, but like I say, I think we can forget about VBScript. Edge no longer supports it, so it's no longer really a valid way to attack things on the web, at least not as common. So there's many ways to beat sanitized characters, and they all work about the same way. So we talked about these mistakes before. Injecting into an event handler is another way to do it. Then there's length limits. So often you have only a small number of characters, like your name or your social security number can only be so long. So you often try to find ways to make really short attacks. This is kind of a fun game people play, trying to accomplish something in the shortest possible injection. So you can send cookies to a server with no host name. This will execute a script with the host name A, and this will go to the server with the host name A, HTTPA, and so on. There's a JavaScript packer online that will try to make your script much smaller. You can span multiple locations. Sometimes if you can inject part of your code in one parameter and another part of your code in another parameter to add them together. So here you put, there's 3 hidden fields, and so you inject this way. The first one gets this much of the parameter, the seed gets that much, and the mode gets that much. So when they're all put together, it constructs your attack. So here's what you have. I put in this value and that part there, and the intermediate parts are ignored because they're turned into comment tags. So here I inject the beginning of my script and the start of a comment. Here I complete the comment and put in part of my alert, start another comment, and so only the bold text is run, and I have succeeded in injecting my script. I have also, by the way, done a lot of collateral damage. I've trashed 3 parameters here to now have invalid values. So there's always a cost. All right, and you can get something from the fragment string. The hash slice will pull that part of the URL, and that's like this DOM-based cross-site scripting we were talking about, where it's taking data from up here in the URL and putting it on the page. And the part after the pound sign is what's called the fragment. So it's another way to sneak data in. All right. And technically that converts reflected cross-site scripting to document object model, because what you insert is script, which now fetches some other part and sticks it in. It's just more and more indirect ways of inserting code. So I think that's enough of that. And let's take a look at the last Kahoot, which is 12C here. I think we need Ed. There we are. That's probably Ed. All right. I'll give it a few more seconds, but I think 9 is all we're getting. All right. So, what attack inserts the first part of a 16-bit character to remove a character? That's the Shift.js attack, where you can inject a character which removes a character that the developer put there, which is pretty awesome. All right, what attack posts a malicious page and then waits for people to visit it naturally? That's the watering hole. A nice trick because the users don't have to get an email or anything where they're clicking on a link, so they feel like they have not taken a risky action, and yet they still get hosed. All right, what character may cause a filter to stop working so script goes through? That's the null byte, which will terminate a string in the C-coded filter, so it doesn't look at the characters beyond that. All right, and what function decodes scripts written in base 64? It's A to B. It's got the strange backward name. Very annoying. Anyway, all right. So Fortega, which I think is, I don't know if that's yet or not. So they're going to tell me who Fortega is. Ken, I know who that is. I think Fortega is not Ed. Maybe it's a real name. Mr. Mephistopheles, that's Ed, I think. So Fortega, is that your real name? Maybe it is. F. Ortega, perhaps. I'm going to just record it as it is. If that's close enough to your real name, my grader will figure it out. Okay, good. Thank you. Good. Okay, good. Fair enough. I see your message, so I will record. All right. And that's what I thought. Okay, good. So I know who everybody is, and I've recorded them. So let me stop this, and I will stop the recording, and I will